Hello students, good evening. Welcome to another video of Vedantu Karnataka. This is Catherine, your physics master teacher. So quickly, can you all let me know if I'm audible and visible? Hi Sumit Kumar. Hi Lucky. Good evening. Welcome to the lesson. Okay. How are your midterm preparations going? All of you. Quickly let me know in the chats how your midterm preparations are going. We'll start in another 2 minutes. Yeah? All set? You only need the paper now? Hi Rupa. Hi Ramesh. Hi Tanisha. Rohit is telling me there's an audio lag. Can some of you confirm if there's an audio lag? Rekha is feeling tough. All set. Rohit is all set for the midterm. So today we are going to do a quick revision, okay? A midterm marathon, okay? Where we are going to discuss all the questions that we've discussed till now. Everything in one shot. Yeah? Ma'am, please give question paper. Yes, Sumit Kumar, next class I'll give you question paper, okay? And I'll give you the answers also. You just have to go write that and then you'll score, okay? Joking, I'm just joking. Please don't do that. All set? No audio lag? There is audio lag. Students, quickly, can you just let me know if there's an audio lag? Let me also check on my phone. Next class I'll give you question paper, okay? I'll give you the answers also. Go write that. Okay. Joking, I'm just joking. I don't find an audio lag on mine. Can you please, all of you, please let me know if there's an audio lag and we'll start immediately. It's an audio lag. Hi Ramesh, welcome to the lesson. No audio lag. Everything's okay. Okay, let's start. So since 2, 3 people have confirmed, let's start. Sunday evening and doing physics, how does it feel? Okay. So we'll start with some 2 mark or 1 mark questions, maybe 2 marks. It was there, now it's all set. Okay, great, Rohit. Great, lucky start. Okay. So I want all of you to revise with me. We're all going to do some quick revision. Chapter 1. Question number 1. State the principle of homogeneity of dimensions. What does the principle of homogeneity of dimensions say? It says that for any physical quantity, dimensions on the left hand side should be equal to the dimensions on the right hand side. Yes? So the equation should be dimensionally correct. So if you have an equation with dimension L on one side, the other side also should have a dimension L. Even if it is L plus L, it's okay. Okay? Even how many ever L's are there, it's okay, but it should all the terms should have the same dimension. So if one term has the dimension L, all the other terms should have the same dimension L. Okay? Yes, yeah, I think it's visible. Is it stuck? Am I stuck? Okay. Give any two limitations of dimensional method. So two limitations of dimensional method is first thing, see constant numbers like 2, 5, maybe 5, which is 3.14 or 1 by 2. All of these, they do not have dimensions. See, we have dimensions only for mass, length, time. Mainly, MLT are the three things that we mainly do. Yeah. So for 2, there is no dimension. For so numerical constants have no dimensions. And we've already learned, you might have, I mean, not in this class, but you might have already learned that dimensions are used to check if an equation is correct. So if the dimension of the LHS is equal to the dimension of the RHS, then the equation is correct. But what if it is an equation which has trigonometric functions? An equation with sine theta, or an equation with e raised to x, or an equation with dx by dt? then you can't check if it is correct. Okay? So it cannot be used to prove correctness of an equation involving quantities like trigonometric functions or derivatives. These are two limitations of dimensions. Next question. Write the SI unit and dimensional formula for moment of inertia. Students, this is just a random, quantity that I've taken. So instead of moment of inertia, they could ask you anything. They can ask you to write the SI unit and dimensional formula of impulse, or maybe force, or maybe work done, maybe power. Anything, whatever it is, you should be able to do it. Okay? So for moment of inertia, to answer this question, you need to know formula. There's no other escape, you can do there. Moment of inertia, the formula is mr square. So what will the dimension be? The dimension of mass is m. The dimension for radius is what? Radius is a length. So it's going to be L square. What would the unit be? The unit will be, the unit of mass is kilograms. The unit of distance or length is meters. So kilogram meter square. So SI unit is kilogram meter square. Dimension is ml square. Students, is there a break in my video and audio? Because on my phone I feel there's a small break. Next question. What are basic units? Give one example. So what are basic units? Basic units are fundamental units. Yeah. And they cannot be derived from other quantities. For example, if you look at force. Yes. Force is what? Mass times acceleration. So the unit of force is derived from the unit of mass and acceleration. But what about mass? Mass is not derived from anything. It is a basic quantity. So the unit of mass, which is kilogram, is a basic unit and is also called a fundamental unit. Another thing, let's say speed. Speed is distance by time. So the unit of speed is derived from meter by second, which is the unit of distance and the unit of time. But distance is not derived from anything. So distance is also a basic unit or a fundamental unit. So the unit of distance is meter. So kilogram, meter, all these are basic units and are called fundamental units. They cannot be derived from anywhere, but you can derive other quantities from that. Okay? Electric current has its unit amps. Yeah. So that unit amps is not derived from anything else. Okay. That's why. Okay. Next question. Motion in a straight line. First question. Two differences between instantaneous speed and instantaneous velocity. So instantaneous speed is, the speed of a body. Instantaneous velocity is the velocity of a body at one particular instant. The difference between the two is that instantaneous speed has only magnitude, whereas instantaneous velocity has both magnitude and direction. So they can be positive and negative because it has direction involved. See, for velocity, if someone's moving in the forward direction, if he has a positive velocity, if he is moving in the backward direction, then he will have a negative velocity. Yes. Yes. So that is why it depends. It can be positive or negative because direction is involved. Instantaneous speed tells us how fast an object is moving at a specific momentum, while instantaneous velocity tells us how fast and in what direction the object is moving. Okay. So main differences between speed and velocity, which is magnitude and direction. Next question, draw a position time graph for a body moving with constant speed. So what should you have? You should have time on the x-axis, position on the y-axis. Okay. So for constant speed, he should be covering equal distance in equal intervals of time. So he should be having a straight line. Now, if I draw a graph like this, what does it mean? It means he's at the same position for a long time. So he is at rest. Okay. So this is the answer. Bhavana, these are all important things in physics. Okay. Yes, I've already discussed important 2 markers, 3 markers, 5 markers. You can look at those videos as well. All right. What happened to Nitin Kumar? What is so funny? Next question. Define average velocity and uniform velocity. So average velocity is what? Average velocity is what? Displacement by time. So average velocity is what? It is total displacement by total time. Yeah? Yes. So you can know how fast a body is moving. Yeah. Next. Uniform velocity means that the object moves in a straight line with constant speed and fixed direction. So uniform velocity is when it moves in a straight line with constant speed and fixed direction, which means the velocity is not going to change with time. So if this is A and this is B, okay? Let's say a body is moving from A to B, and every 10 seconds he covers 10 meters. Okay, the next seconds he covers another 10 meter. In the next seconds he cover another 10 meter. So in every second he keeps on covering 10 meters. So you can see that the total velocity, which is distance by time, is going to be the same. That is uniform velocity. Yeah. So 10 by 10 is what? 1. So 1 meters per second is the velocity at every point between A and B. So that is uniform velocity. That means the velocity is not changing with respect to time. For average velocity, what should I do? I should add all these. So 10 plus 10 plus 10 divided by 10 plus 10 plus 10, and then I will get average velocity. I add the total displacement, I divide it by total time. Okay, next question. A body moving with an initial velocity of 5 meters per second and uniform acceleration of 1 meters per second square, determine its velocity after 20 seconds. Very easy. Initial velocity is 5, acceleration is 1, time is 20. Let's substitute. V is equal to U plus 80. So this is basically 5 plus 1 into 20, which is 5 plus 20, which is 25 meters per second. Okay. Hello, Navnita. Welcome to the lesson. Average velocity with an example. See, let's say from A to B, the displacement is, let's say, first half displacement is 10. Second half displacement is 20. What is total displacement? 10 plus 20. Okay? That one divided by how much ever time it takes. Let's say first it takes 5 seconds. Then it takes 5 seconds. Total 10 seconds he reaches from A to B. So total average velocity is what? The total displacement divided by the total time. Okay. Next question. Motion in a plane. First question, define scalar product of two vectors. Give an example for scalar product. Scalar product is very easy, students. If you have a vector A, okay, and then you have a vector B. Let's say you add them, and then A and B are at an angle. They have an angle theta between them. So to find out scalar product is also called as dot product. To find out scalar product, what you do? You do it as A dot B. Okay? So scalar product, you put dot. So you take it as A dot B, and A dot B is basically the magnitude of A multiplied by the magnitude of B multiplied by the angle between them, the cos of the angle, which is cos theta. Okay? So A, B, cos theta. Now if you want to find out the resultant, what you should do? So let's say this is A and this is B. Okay? Here the arrows should be let's say this is A and this is B, and you want to find out the resultant R. What you should do is you should take R is equal to square root of A square plus B square plus 2AB cos theta. Okay? That's how you do it. Next question. Write the expression for time of flight of a projectile motion and explain its terms. T is equal to 2u sine theta by g. What is u? U is initial velocity, theta is angle of projection, g is the acceleration. Write the expression for range of a projectile and explain its terms. Explain its terms. Range is what? What is range actually? See, if this is a projectile, from here I'm throwing a javelin. So let's say I'm throwing it like this and it reaches here. This is the range. Okay. Now let's say if I'm throwing it till here, then what is the range? This is the range. Okay. So the range keeps on changing. Okay. So the maximum range is what you find out using this formula. Next question. Centripetal acceleration. Write the expression for centripetal acceleration and explain the terms. Centripetal acceleration AC is basically V square by R, which is velocity, okay, divided by radius. So if this is a racetrack, okay, and let's say you are running, okay, and if you want to find your centripetal acceleration, you have to know the radius of the track that you are running and at what speed or what velocity because direction, right? At what velocity you are running. If you divide it, you'll get your acceleration. Centripetal acceleration is always pointed towards the center. Okay, next is from laws of motion. Two physical quantities which are defined on the basis of Newton's first law. Force and inertia, they're both defined on the basis of Newton's first law. Write an expression for momentum in vector form and explain the terms. What is momentum in vector form? P is equal to mass into velocity, where m is the mass and v is the velocity. SI unit and dimensional formula of momentum. This could be a question from chapter 1 also, but since momentum you learn in this chapter, I just put it here. So for momentum, what is momentum? The formula for momentum is mass into velocity. What is the unit of mass? Kilogram. What is the unit of velocity? Meters per second. So this is kilogram into meters per second. So the unit will be kilogram meters per second. So what would the dimension be? The dimension will be the dimension of kilogram is mass, meter is length, divided by time. So t raised to minus 1. Okay. Next question. Distinguish between mass and weight. See, what is the difference between mass and weight? Mass is the amount of stuff in your body, the amount of matter in your body. For example, your blood cells, your muscles, your bones, your ligaments, tendons, all that together gives you your mass. And it's going to be the same everywhere. Even if you go to the moon or go to space or you're on Earth, your mass is going to be the same everywhere. This mass, when it's pulled down by gravity, that's when you get your weight. Okay? So weight is mass times gravity. Okay. Yes. 5 marks questions are there in this video itself. So we'll start with 2 and then go to 3 and then we will do 5. Don't worry. Okay. Nitin Kumar, I right now don't have a board set up with me. I'm taking class on my laptop. That's why I'm sitting. Okay. Yeah. All right. It's not because I'm lazy to stand. All right. I hope you understand. That's a technical issue that we have. We don't have a board with me. I don't have a board with me right now. Okay. Next question. Write Newton's second law in component form. So what is Newton's second law? Newton's second law is generally F is equal to ma. Yes. Students, is there a disturbance? There's some event happening outside. Is there a disturbance happening here? Can you hear that? Okay. Next question. Write Newton's second law in component. So what is Newton's second law? Newton's second law is so a law F is equal to ma. Yes. Students, is there a disturbance? There's an event happening outside. Is there a disturbance? Okay. So along the x-axis, it's going to be Along the x-axis, it's going to be m times ax. Yeah. Along the y-axis, it will be m times ay. Along the z-axis, it will be m times az, because acceleration it depends on direction. So it can go along x-axis, y-axis and z-axis. Okay? Yes. Next question. Hi, Srinivas. State and explain Newton's laws of motion. What is Newton's law? First law. If you have a book on a table, it will continue to be on the table forever unless and until an external force is applied on it. Yeah. So if a body is at rest, it will continue to be at rest unless and until an external force makes it move. Or if a body is moving, it will continue to move forever unless and until an external force makes it stop. Okay. So if there's a ball that's rolling on the ground, yeah. If there's a ball that's rolling on the ground, and why does it stop? It stops because friction. There is friction. Imagine a world with zero friction, no friction. Then what would happen? This ball would roll forever and ever. Yeah, so that's Newton's law. Sumit, I don't think I can answer that because these are all past year questions and questions from your PU board. So if you get these questions, you will be able to score really well. Yeah, let's hope that you get these questions. Mention the significance of components form of Newton's second law. So the main significance of component form of Newton's law is that you can find out what is the force along x-axis, what is the force along y-axis, what is the force along z-axis. You can resolve that. That is the main advantage. Okay. What is impulse of a force? Impulse of a force is large force acting on a short time. Like this. So right now, let's say I'm, putting my hand on my table and I'm doing it sometime. I'm applying a force on the table, but I'm doing it for some time. So that is not impulse because I'm applying this force for some time. But let's say if I'm hitting, I'm applying a huge force, but for seconds. That is impulse. So if you apply a large force for a very short time, that is called impulse. Okay? Yes. That the definition is also given here. Impulse is the product of force and time duration. Force into time. Force into time. Okay. State and explain Newton's third law of motion. What is the third law of motion? If A applies a force on B, B applies an equal and opposite force on A. Yeah. So let's say A applies a force F12 and that will be equal to minus of F21. So A and B apply opposite forces on each other. Impulse depends on the force that you apply and how fast. It should be a large force and it should be quick. Okay? Yeah. Yeah. Hi Kushala, welcome to the lesson. Okay, next question. Give an example which illustrates the law of conservation of linear momentum. So first thing is recoil of a gun when a bullet is fired. So imagine when I'm shooting, I have my gun. So when the bullet, I press and then the bullet goes out. So when the bullet goes out, the bullet goes in the forward direction with a momentum. It also exerts a backward momentum on the gun. So there is a momentum in the forward direction and the backward direction, which means momentum is conserved. Momentum towards the forward direction and the backward direction, they're both the same. Okay, next one is to state the principle of rocket propulsion. What is it? See, forward and backward momentum should be the same. In a rocket, what happens? The rocket moves forward. How does the rocket move forward? By expelling gas backwards. So when gas comes out of the rocket, what happens? Rocket moves forward. So gas moves back with the momentum. Rocket moves forward with the momentum. Both these momentums are equal and opposite. Okay? Backward momentum, forward momentum, both are equal and opposite. Mention the common forces in mechanics. What are the common forces? Gravitational force, normal reaction force, frictional force, tension, applied force, anything like that you can put. Yes? Okay. Common forces in mechanics. What are normal reaction and friction? What is normal reaction and friction? Students, imagine you are standing on a table. On the ground, you're standing on the floor. And let's say you're walking. When you're walking, what happens? There is friction. This friction between your legs and the ground. Yes. What is normal reaction? Normal reaction is the force perpendicular to the force, the other force exerted. I'll give you another example. Let's say there's a book on a table. So the book has its force acting in the downward direction because of its weight. And this is mainly because of mass and gravity. So in the downward direction, there is mass and gravity. And in the upward direction, what does it have? It has a force called as normal reaction force. Now, what is normal reaction force? Normal reaction force is the force which is equal and opposite to weight. Yes? Yeah. Otherwise, what will happen? See, imagine there's a book on a table, okay, and there's only weight acting in the downward direction. What happened? There's something pulling the book down. The book would, break the table and go inside. Yeah, yeah. But that doesn't happen. The book stays at rest on the table. Yeah. So what does that mean? There is an equal and opposite force in the upward direction, and that force is normal reaction. What are contact forces? Forces that act through contact. For example, when I rub my hands, there is friction. Friction occurs only when I rub my hands. If I keep my hands like this, there is no friction. Only when they touch, there is that force. Such kind of forces are called as contact force. Friction have two types. What are the two types? Static friction, kinetic friction. Okay. Yeah. And what are the advantages of friction? It helps us in walking, driving, writing, anything. Yeah. Now, this kinetic friction also has two types. What are they? Static friction and rolling friction. Okay. So, what is static friction or sliding friction? Sorry. Sliding friction. Really sorry. What is sliding friction? When two surfaces slide against each other. For example, my hand on this board. I'm sliding. Now we experience sliding friction. Now imagine there's something like a ball and it's rolling, 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 rolling. Then it experiences rolling friction. A ball rolling on the ground. A box sliding on the floor has sliding friction. A ball rolling on the ground has rolling friction. Okay? Now, what is banking of roads and why is banking of roads necessary? So, if you have a road that's flat, if you go, above a certain speed, your vehicle might skid. To prevent that, what we do is, if this is a road, what you do is, you slightly lift the road like this. So the road would be kept at an angle. So you can see that on hairpins, roads are not kept flat. They're always lifted. That's because on a banked road or on a lifted road, you can move your car or you can drive at a slightly higher speed without skidding. So on a flat road, if you can go with a speed of 50, maybe if you bank it, if you lift it, you can go with a speed of 55, maybe. I'm just putting random numbers. Okay. So banking of roads help us move with an extra speed. It provides an extra force. So it helps the vehicle turn safely. Okay. Yes. Ma'am, what you said in the last class came in exam. Thank you. Happy to hear that. Yeah. I don't want to give you, false hope saying that only this will come. I am hoping that this will come because this is what I've got from a lot of research. I've done a lot of homework and I've taken these questions, but you can never say. You might have different questions. Okay. But the only thing we can do is prepare with whatever we have. Yeah. So hopefully these questions will come. Yeah. I am confident that these questions will come. But yeah. What is banking of roads? Yeah, this we already answered. Next question. A constant force of 8 Newton is applied to a body of mass 3 kg. Find the acceleration. So F is equal to ma. So what will A be? 8 by 3, 2.66. An object accelerates at 2 meters per second. What is the magnitude of the force? F is equal to ma. What is acceleration? 2. Mass is 10. So you multiply. You will get 20 newtons. Okay. Now, a body of mass 1.5 kilogram has linear momentum of 6 kilograms meter per second. Find its linear velocity. How will you do that? So, momentum is mass times velocity. So, velocity is momentum times mass. So, it will be 4 meters per second. Okay. Next question is from work, energy, power. That momentum is mass times velocity. So velocity is momentum times mass. Students, there's a event happening here. Okay. Just a second. There's an event happening here and there's a lot of noise. I'll just get back to you. Yeah. I'm here, Sumit. Can you hear me now? So at any point, if there's a disturbance, please do let me know, okay? Because it's Dasara and there's a lot of programs happening, so there's a lot of background from outside. I'm really sorry. So if there's any disturbance at any
Sumit,
point,
can you hear me now?
you have to let me know. Okay? Yes, next question. Necessary conditions for work done. How do you know when work is done? So, how do you know when work is done? If you apply a force on a body and then the body, undergoes some kind of displacement, then you can say that work is done. For example, if I keep on pushing the ball, then no work is done. But if I push the wall and the wall moves, if I'm Hulk, okay, I push the wall and the wall moves, then work is done. Okay? So if you apply a force and work is done, that is when, sorry, if you apply a force and there's movement, this has a displacement, that is when work is done. So whoever's there in class, can you quickly let me know if there's any background that you can hear? Or is my voice clear? Quickly let me know. State conditions under which no work is done, or write the condition for zero work done. As I already said, you're applying a force and there's no displacement. Then there is no work done. Or if they're perpendicular to each other. Okay. So let's say I'm applying a force and the displacement is perpendicular, then there is no work done. Yeah. What are the conditions for maximum force and minimum force? Maximum force is when theta is 0 degree and minimum force is when theta is 90 degree. Because we know that work done is F dot S, which is Fs cos theta. So if it's cos 0 and cos 90, depending on that, you will get maximum work done and minimum work done. Okay. So students, all those who are there in class, can you let me know if my voice is good? If there's any disturbance, please let me know. Okay? Yeah, because there's a lot of music outside. I don't know if you're able to hear it, but I am. Can acceleration be produced without doing any work? Yeah. Yes. Acceleration can be produced without doing any work. So in centripetal acceleration, what happens? In centripetal acceleration, what happens? Acceleration is perpendicular to velocity, so no work is done, but still there is acceleration. Yeah. Next is SI unit and dimension of work. See, work and energy, they both have the SI unit joules. They have the same energy. How will you find out the dimensional formula? Work is force into displacement. So SI unit of force is, and force multiplied by displacement will be ml square t raised to minus 2. Yes, I will do that. K, gorgeous, don't worry. Students, please let me know if there's a disturbance in the background. Are you able to hear some music or you're able to hear only my sound? If it's clear, can you all put clear in the chat? Yeah? Quickly, if there's no audio problem, please put clear in the chat. Next question. What are conservative and non-conservative forces? Give example. Conservative force is a force that's independent of path. Okay, so let's say this is A, this is B. However, I reach B. Yeah. However, from A, however I reach B, work done is going to be the same. That is conservative force. But non-conservative force is something that depends on path. Okay, so if I reach AB like this, it's going to be different. If I reach AB like this, it's also going to be different. Okay, so it is independent of path. All right. Okay. Next question. Write the SI unit of energy and write its dimensional formula. Thank you, Sumit. So energy and work done, they have the same dimension, same unit. So it's the same thing. Joule and ml squared t raised to minus 2. Next question. Name two types of mechanical energy. What are the two types of mechanical energy? Kinetic energy and potential energy. Yeah. Kinetic energy is the energy of a body when it is moving. For example, when I'm running, I have kinetic energy. When I'm walking, I have kinetic energy. Whenever a body is moving, it has kinetic energy. What is potential energy? Potential energy is the energy that's stored in a body because of its position. For example, when I'm sitting, I'm at rest. Because of my position, the energy that I have is potential energy. Now, if I'm on the fifth floor, you have different potential energy. So it depends on position, but it's the energy of a body with where I am at rest. Okay. Sumit Kumar, you can share to me on Telegram. Okay. Yeah. So you can just search my name on Telegram. Or there's Vedantu Karnataka. There also you can share it. Yeah. Okay. State and explain force law for the spring. What is the force law? States that if you have a spring, okay, and you extend the spring, extension, how much ever the spring extends, it depends on how much ever force is applied to the spring. Okay. So for example, if this is a spring, yeah, the same spring, I apply a force. Depending on how much force I apply, the spring extends. So more the force, more the extension. So I can say force and extension are proportional. Yeah. More the force, more the extension. Yeah. So extension here is represented by alphabet X. So F is proportional to X. Now I add a constant. The constant is called spring constant. Okay. Students, my audio is clear, right? No background noise. Yeah. Is there any background noise? If there's background noise, please put yes in the chat. If there's no background noise, please put no in the chat. So I know. Yeah. So what is spring constant? So if you have two springs, okay? Let's say this one has a spring constant K. This has a spring constant K2. K1 and K2 gives you the stiffness of springs. So if K1 is more stiff, it will have a higher spring constant. If K2 is more stiff, it will have a higher spring constant. So higher spring constant means more stiffer spring. So spring constant K tells us how stiff the spring is. Okay, next question. Show a graph of variation of kinetic energy and potential energy attached to a vibrating spring which obeys Hooke's law. So it's just a simple graph. Okay. Let's say this is the upper limit and lower limit. So this line represents total energy. So since energy is conserved, kinetic energy plus potential energy should always be the same. So the uphill arrow, this represents kinetic energy. The lower one represents potential energy. So when kinetic energy is maximum, potential energy is zero. Potential energy is maximum, kinetic energy is zero. Only then kinetic plus potential can be equal to a constant, which is total energy. Okay. Okay. Next question. Different forms of energy: mechanical, thermal, chemical, electrical, so many different forms of energy. What is the unit of electrical energy? The unit of electrical energy is kilowatts per hour. Now, 1 kilowatt per hour is basically equal to 3.6 into 10 raised to 6 joules. Okay. So that is kilowatts per hour is the unit of electrical energy. Now, name a physical quantity which is measured in HP. HP is not just your laptop company, but HP also stands for horsepower. Okay. So power is measured by HP and HP represents horsepower. So 1 horsepower is 746 watts. So we've already learned that the unit of energy or the unit of power, sorry, the unit, not energy, the unit of power is watts. Another unit of power is HP. Okay. And the relation between HP and watts is what I just gave you. Okay. Next question. Write the SI unit and dimensional formula for power. SI unit we already learned is power. Dimension will be what? Power is basically energy by time. So the dimension for energy we already know is ml square t raised to minus 2. We've already learned that divided by t. Yeah. So this goes up, it will become t raised to minus 3. Okay. Next question. Show that P is equal to F dot V where the symbols have their usual meaning. Power equals F dot B. So we already know, what do we know? We know work done is force times displacement. Yeah. And we also know that power is dW by dt. Now instead of this W, I will substitute this as d by dt F dot S. Yeah. Since F is a constant, I'll take F outside. So this will be F times d by dt into S. Okay? Yes. F dot d by dt into S. Now ds by dt is what? ds by dt is change in speed by change in time. Sorry, change in displacement by change in time, which is v. So this is basically F into v. Okay? Very easy. Okay. Let's move on to the next question. Mention the type of collisions. There are two kinds of collisions: elastic collisions and inelastic collisions. Okay. What is an elastic collision? Elastic collision is a collision where kinetic energy is conserved. So kinetic energy before the collision and after the collision, they are both going to be the same. Inelastic collision is a collision where kinetic energy is not conserved. Okay, so the kinetic energy before and the kinetic energy after are not going to be the same. Now, distinguish between elastic collision and inelastic collision. Same thing. Kinetic energy conserved, not conserved. A constant force of 8 Newton is applied to a body which displaces it through a distance of 9 meters in the direction of the applied force. Find the work done by the force. Work done is what? Force into displacement. So this is basically 8 into 9, which is 72 joules. Next question. An object of mass 10 kg is moving with a speed of 5 meters per second. Estimate the kinetic energy associated with the object. So kinetic energy will be half mv square. So this will be half times 10 times 5 square. So 10 by 2 will be 5. 5 5s are 5 5 5. So it will be 125 joules. Okay. Next chapter, system of particles. First question, what is pure translational motion? See, translational motion is when all the particles are moving parallel. Okay, and they're all moving with the same velocity. For example, a book sliding on a table. So when a book is sliding on a table, all the particles in the book are moving in the same direction with the same velocity. Yeah. Next, what is pure rotational motion? Pure rotational motion is when a body rotates about a fixed axis. Your fan. It has an axis in the center, and from there, the fan rotates. Yeah. And then a spinning wheel. Any of that. So those are all pure rotational motion. Give an example for a body whose center of mass lies inside the body and outside the body. So if you take a sphere, yeah, if you take a sphere, the center of mass is inside the body. Yeah, it's a point inside the body. Now, you need to find out something where it's outside the body. Let's just cut the center of the sphere. Okay, I cut this part of the sphere. Now, what do I have? I have a ring. Yeah, so there was a sphere. The center of mass is at the center. Now, I cut the sphere. I get a ring. For the ring also, center of mass is at the center. Yes, but this is not inside the ring. See, the ring is only on the border. A point inside the ring is outside. So, center of mass for a ring is outside. Next question. What is mechanical advantage of a lever? The mechanical advantage of a lever. See, what is lever or lever? Okay, it's basically the ratio of output force to input force. That means how much output, how much work you do, divided by how much force, how much work you give. For example, what example should I give? These trolleys, yeah, shopping carts. So you just apply a small force. No, not just shopping carts. Let's take these trolleys which have, a wheel, and then you hold it like this. You carry them. Yeah. So for them, you apply a small force, you can carry even huge rocks on it. So that's basically a lever system where force is multiplied. You are applying force, it's multiplied by the lever. Yeah. So it has a factor called MA, which means mechanical advantage. So if mechanical advantage is greater than 1, it means that a little effort, yeah, helps you lift very great objects. Not very great, big objects. Define vector product of two vectors. Give an example. Scalar product, we already saw A dot B, which is AB cos theta. So vector product is A cross B, which is AB sin theta. Okay? Yes. Next is define moment of force. Moment is what? Moment of force is basically torque. It is the turning effect of force about a point of pivot. Yeah. So moment is F cross R, which is force into perpendicular distance from the pivot. Yeah. Students, is there a disturbance now? Please let me know if there's a disturbance. Please put yes in the chat. Mention two factors on which torque of a rotating body depends. Obviously, two things, force and perpendicular distance. Next question. Define angular momentum. Write an expression for it. Angular momentum is what? It is. Ma'am, will they ask formula derivation? Yes, they might. If the derivation is there in your NCRT, they will ask it. Okay. If it's there in your syllabus. Okay. Angular momentum is equal to angular linear momentum. So, what is linear momentum? Mass into velocity. Yeah. Mass into velocity. So, the angular version is angular momentum. Okay. And it is basically I omega. Write the dimension and SI unit of angular momentum. SI unit is what? Kilogram meter square per second. And dimensional formula is ml square t raised to minus 1. Next question, state and explain principle of conservation of angular momentum. Say it just remains constant. It's conserved. That's the conservation part. An example is, Earth revolving around the sun. So the angular movement is conserved there. Okay? Spinning ice skater pulling in arms to spin faster. Okay? Okay, next question. Define moment of inertia. We already discussed. I is mr square, SI unit kilogram meter square. We already discussed. Mention two factors on which moment of inertia of a rigid body depends. Moment of inertia depends on only two things. What are they? The mass and how it's distributed with respect to the axis of rotation. Two things. Define couple. What is couple? Not the couples that you have in school or college. This couple is basically two equal and opposite parallel forces that cause rotation. Yeah. So if two forces cause something to rotate, for example, here, I push it like this and like this, what happens? This will rotate. Yeah. So one force is this way, one force is this way. So the forces are equal, but they're in opposite directions. And what does that make? What does that happen? What effect does it produce? This way and this way, it makes this body rotate. Okay. And that's also given by the formula for torque, which is F cross D. Okay. Give two examples for a couple. Turning a steering wheel. How will you turn a steering wheel? Like this. One force up, one force down. Or like this. One force up, one force down. Okay. So two equal and opposite forces that produce rotation. Okay. Next question. State the principle of moments. What is mechanical advantage? Already discussed. What is mechanical advantage? What is mechanical advantage? It is the ratio of load effort to effort force. Already discussed. Give the general conditions of equilibrium of a rigid body. Net force on the body is 0. Net force on the body is, net torque on the body is also 0. Okay? Why a flywheel is used in engines? It stores rotational energy, so there's no fluctuations and there's uniform motion. Okay? What are the factors on which moment of inertia of the body depends? It depends on the mass, it depends on the shape, it also depends on the axis of rotation. Simple question. To maintain a rotor at a uniform angular speed of 200 radians per second, an engine needs to transmit a torque of 180 newtons meter. What is the power? So power is basically torque times omega. So this is going to be 180 into 200, which is 36,000, which is 36 kilowatts. Okay. Next is gravitation. Moon has no atmosphere. Why? That is because it has no gravity. See, how is the atmosphere being present around the earth? Because the earth's gravity pulls the atmosphere, it makes it stay there. But moon has no gravity, so it does not have the strength to hold the gases. Okay? Define gravitational potential energy of your body, give an expression for it. So gravitational potential energy is minus gmm by r. Yeah? So G is gravitational constant, m is mass of the earth, small m is mass of whatever body is there, r is the center of earth. State and explain Newton's law of gravitation. Yeah? What does Newton's law of gravitation say? Let's say there are two masses. These two masses experience a force between them. Okay? And that force is directly proportional to the product of the two masses. Yeah? That force is also inversely proportional to the radius square between the distance between the two masses. Okay? So if I have two masses here, they have a force between them. It depends on this mass multiplied by this mass. It also inversely depends on the distance between the two masses. When you remove the proportionality constant, this becomes m1 m2 by r square with a g in front. Okay? What is escape speed? Give its value in the case of Earth. See, escape speed is what? The minimum speed needed for an object to leave Earth's gravitational field. Okay? So this is the Earth. Yeah? And let's say there's a rocket. Okay? So this rocket has to escape Earth and go to space. So it has to go at a speed higher than 11.2 kilometers per second. Okay? Next question, define orbital speed of a satellite around the Earth. Orbital speed of a satellite is given by V equals gm by r. G is gravitational constant, m is mass, r is the distance. Why does an object weigh more at the surface of the Earth than at any point? That is mainly because of gravity. Okay. So gravity at the center of the Earth is 0. Yeah. So it decreases with depth. So on the surface of the Earth, G is 10 or 9.8. And as it goes here, it's 0, it decreases. Yeah? That's why the object's weight will change. Next question, what is a satellite? Satellite is any object that revolves around another object because of gravity. So Earth has only one satellite, which is the moon. Yeah? And why do we need artificial satellites for communication, for television broadcasting, for weather forecasting, and all of that things? Both radius and mass of a planet are 2 times that of Earth. Calculate the acceleration. So G is what? Gm by r square. And m is 2m. R is 2r. So what I will substitute? I'll substitute that here. So this will become G into 2m. R will become 2r. And then what will I do? I'll just, take out the common terms. So this is basically 2 by 4 gm by r. So this gm by r I already know. It's what? Ge. So 2 by 4 is 1 by 2. So this becomes 1 by 2 Ge. And then math. Simple maths. Okay. Next question. The radius of the Earth is RE. Find the depth at which acceleration due to gravity is half the acceleration due to gravity at the surface of the Earth. So acceleration due to gravity at a depth is half from acceleration due to gravity on the surface of the Earth. So GD is half into G. Okay. So if I know G, then G by 2 should be 1 minus D by RE. So I already know that GD is equal to G1 minus D by RE. Yeah. So I can write this as G by 2. Yeah. Instead of GD, I can write it as half G. So G and G cancels, and then I'll get half is equal to 1 minus D by RE. So from here, I will get D is equal to RE by 2. Yeah. Okay. With this, we come to an end of 2-mark questions. We'll discuss the 3-mark questions after a 5-minute break. Um, 6:50. Okay. So Hello, everybody. Welcome back. Let me erase this. Yeah. Okay. Next, 3 markers. Question number 1. Am I audible and visible? Let me just check that once again. Ma'am, how to pass? Any idea to pass? Watch all Vedantu Karnataka lectures. All subject lectures are there. Important questions are there. Okay? Yeah? You will pass. Okay? Yeah. Question. Check the dimensional correctness of the equation x is equal to ut plus half at square. How to do that? Let's quickly do it. X is equal to ut plus half at square. How to do it? So first thing, dimension for x is what? X is a length. Yeah. So the dimension for length is L. Okay, perfect. The dimension for acceleration is what? Lt raised to minus 2. The dimension for t is t plus. Half has no dimension. Let's ignore it. Acceleration again has a dimension Lt raised to minus 2. Time has a dimension t square. T square has a dimension t square. So one small correction here. This is ut. Am I writing mistake? This is u. So this is Lt raised to minus 1. Okay. Now let me solve this. Lt raised to minus 1 and t. What will happen to the 2? I can cancel them. Lt raised to minus 2 and t square, I can cancel them. So now I get L equals L plus L. Now you can see all the 3 terms, x, ut and half at square, all the 3 terms have L as the dimension. So this equation is dimensionally correct. Yes? Students, is there a disturbance here? Please let me know if there's a disturbance. Because I'm not taking class at night. It's just 6:20. So there's disturbance and I'm not in the studio. Okay, that's why I want to make sure that there's no disturbance. Okay, next question. Check the dimensional correctness of the equation. How will we check the dimensional correctness of the equation? So the equation is t is equal to 2 pi square root of L by G. Yeah? 2 pi does not have dimension. So let's write down the dimensions of the terms that we know. T has a dimension T is equal to length has dimension L. What is the dimension of gravity? Gravity and acceleration have the same formula and same dimension. So the dimension is Lt raised to minus 2. Okay. So this is what L and L cancel. So this is basically T square. This is square root, square root. Square root of T square is what? T. So T is equal to T. Yeah. So now the equation is dimensionally correct because both the LHS and RHS have the same dimension, which is T. Okay. Yes. Okay. Next question. Students, do we have okay, I don't think there's any disturbance. Let's continue. Derive the expression for period of a simple pendulum which depends on its length, acceleration due to gravity, G using dimension analysis. Yes, Chetan, I will do a class on numericals. Don't worry. Okay. Does any 1 second? Yeah. So here we have to derive the expression for time period of a simple pendulum. So we know that we have to derive an expression for time period. So you put time period there. Yeah. And then you say that this is equal to some constant K. Yes. And then what is the first term? It depends on length. So L. But we don't know if it depends on length square, length cube, or square root of L. We don't know that. So we'll just put L raised to A. It also depends on gravity. So I'll put G raised to B. That's all. Now very easy. So I will write down the dimensions. What is the dimension for T? T is equal to, dimension for length is L, L raised to A. Dimension for gravity is L T raised to minus 2, the whole raised to B. Yeah. Now I'm going to equate the dimensions for T. First thing I'll take T. T is T raised to 1 on the LHS is equal to, on the RHS it is what? Minus 2B. Yeah. T raised to minus 2B. That's the only thing there. So the power of T is minus 2B. So from this, can I write B is equal to minus 1 by 2? Yeah. Okay. Now for A, what do I do? A is 0 on the LHS. There is no L raised to something on the LHS. So it's 0 is equal to L raised to A. So A plus L raised to B. So B. This is basically 0 minus 1 by 2. I already know B is 1 by 2. So I will get A is equal to 1 by 2. Yeah. So now let me substitute that here. So T is equal to K times L raised to 1 by 2, G raised to minus 1 by 2. So this is basically K times square root of L by G. Yeah. G raised to minus 1 by 2 means G goes to the denominator. And both are raised to 1 by 2, so square root. So T is equal to K times square root of L by G. Okay? Yes, they are important if it's there in your syllabus, if it's there in your in your syllabus, then it's important, Miss Unique. Yes, Chetan, I will give you the PDF. It will be uploaded on Vedantu Karnataka Telegram channel. Okay, so you can just go to the video links under the video. There's a link to join the Telegram channel. You can join it and get the notes there. Okay. Next question. Derive the expression for V equals U plus 80 or V equals V naught plus 80. See, U and V naught, they're the same thing. First thing is graph. Okay, first thing is graph. How will you draw the graph? Velocity on the y-axis, time on the x-axis. So this is the starting point. So this is initial velocity u and it goes till here. This is final velocity v. So this much is what? V minus u. No, this much is v. This much is v minus u. This part. Yeah. This part is u. This part is v. This full thing is v minus u. Full confusion. Full thing is v minus u. Okay. All right. Yes. All those who are watching this, can you please give me a like on the video? Quickly mark your attendance by liking the video. Let's make it at least 50 likes in this video. Okay. Quickly like the video. Okay. So the velocity at any time t is given by v equals v naught plus at. Yeah. So to find this, what we do is we're going to find out the area under the graph. So you can do it in two ways. You can divide this into a triangle. Yeah. So area of triangle plus area of rectangle. So area of triangle will be half times base is time times height is what? V minus u plus area of rectangle will be u into t. You can do this. So this will become half v minus u t plus ut. Yeah. Yes. And then what I will do is half v minus u into t plus u into t. And then you can substitute the value of t. What is t going to be? V minus u divided by a. Yes. I'm just thinking if I should do the whole thing. I've already written it here. Okay, anyways. So this is going to be equal to half times v minus u into v minus u by a plus u into v minus u by a. So there's a common here. Okay. X is equal to. And then what you can do is you can just equate it. Yeah. So v minus u into v minus u will be v square minus u square. So from this you will get x is equal to v square minus u square divided by 2 times a. Yeah, when you're equating this. So this bracket you have to cross multiply. When you're equating this, you will get this. And then what you should do is you should cross multiply. So 2ax is equal to v square minus u square, and then rearranging you'll get the answer. But apart from that, you can do it in another way where you take the whole graph as a trapezium. That's another method where you can use. So you take this whole graph as a trapezium. Okay? So when you take this whole thing as a trapezium, what should you do? Sorry. Yeah. And then what should you do? You take the whole thing as a trapezium. So area of a trapezium will be x is equal to half times the parallel sides. Yeah. So it will be V is one parallel side plus V naught into base. So it's basically half times A plus B into T. A is, if this is a trapezium, this is A and then this is B. Okay. So the parallel sides and then you just multiply them. Okay, next question. Same thing. V square is equal to same thing, no? Yeah. Next question. Mention 3 applications of velocity time graph. What is it used for? It is used to determine acceleration of an object by calculating the slope. If you find out the area, you get displacement, okay? And helps you predict how a body moves. It helps you predict the nature of motion. Next question. A car is moving along a straight road with a speed of 126 kilometers per hour. Okay. So let's say speed is 126 kilometers per hour and distance x or s or x is 200 meters. What is the retardation? I don't know the formula for retardation, so I will find out acceleration. So v square is equal to u square plus 2as. Yeah. So what is v going to be equal to? The car is stopping. The car is coming and it's stopping. So v is going to be 0 and u will be how much? 35. How did I get 35? I converted 126 into 35. 126 into 5 by 18. So 35 square plus 2 into a into 200. You do the math, you will get acceleration is minus 3.06. I've already done it here, that's why I'm not going to do it again. Okay, I want to finish this one shot in less than 4 hours, that's why. Okay. Next question. A stone is thrown vertically upwards with a velocity of 20 meters per second. Calculate the maximum height reached by it, where g is 10 meters per second square. Okay? So this is thrown up with a velocity of 20, yeah? And then it's going to be at a height of, gravity is going to be 10. Okay? Same thing formula. What is the formula? B square equals U square plus 2AS. So here I'm throwing the ball up. So acceleration is going to be minus G. So V square is equal to U square minus 2GS. Yeah? Direct substitution. Yeah? Acceleration is given 10. 2 you know. U is 400. You will get the answer. Not solving these because the answers are already there. Okay. Next question. Motion in a plane. Explain the triangle method of vector addition. So if you have two vectors, A and B. So here what you can see is vector A and vector B are, at an angle. Yeah. So this is like the resultant. So how they should be placed is that, so vector A, okay, and vector B, the head of vector A should be touching the tail of vector B. So head and tail, they should touch each other. Okay. And R is the resultant. Yeah. R is the resultant. Okay. So you should always place the head of one to the tail of the other. Head and tail should meet. Only then you can get the resultant as the third side of the rectangle, triangle. Okay. So you can just read out what I've written here. Everything is clear. Place the tail of the second vector at the head of the first vector. So you can see tail of B is at head of A. The vector drawn from the tail of the first vector to head of the second vector represents the resultant vector. This method visually adds vectors by connecting head to tail. Okay. Next question. If A is 3i cap plus 2j cap and B is I minus 2j plus 3k, find the magnitude of A and B. You just have to add the I cap, J cap, K cap terms together. That's all. Yeah. So A is what? I cap terms are 3 and 1. So 3 plus 1 I cap plus 2 and minus 2 J cap plus 0 plus 3 K cap. Okay. So 3 plus 1 is what? 4 I cap plus 0 J cap plus 3 K cap. And then to find out the resultant, what do I do? 4 square plus 0 square plus 3 square. I will get it as 5. Okay, next question. Two forces, 4 newtons and 3 newton, act at a point making an angle of 60 degrees. So I have A, 4 newton, B, 3 newton, theta is 60. Formula is simple. A square plus B square plus cos 2AB cos 60. Okay, I want you all to substitute and check if you're getting 6.08. Yes. Next question. Obtain the expression for time of flight of projectile of a motion. How will you get it? First thing, you need to know the diagram very well. Yeah. So this is the projectile. This is the diagram for the projectile. Yeah. So you have a body that you're moving like this. So when you're moving like this is the x-axis, y-axis, and this is the x-axis. So here, you can see the body is moving up. Yeah. When I'm throwing a javelin, I'm throwing it up and it's landing like this. Since I'm moving up, yeah. Since I'm moving up, U is along y-axis. And this is theta. This is the angle of the projectile. So always the line next to the angle will be cos theta. So this is cos theta. And the line away will be sin theta. So here the x component, ux is basically what? U cos theta and uy is u sin theta. This you should know. And then what we're going to do? Basic equation of motion. V is equal to u plus at. V is 0. Yeah. Because at the maximum height it's 0. U is what? Along y-axis because it's moving along y-axis. Maximum height, right? It's u sine theta. Acceleration is moving up against gravity, so it's minus gt. So t is what? U sine theta by g. Now, this is till from here, from here till the top. Yeah, from here till the top. Now, from here it goes down as well. So, time is basically 2 times the time. First, it goes from here to top, then from here to here. So, it is 2 times the time. So, this is 2u sine theta by g. Okay, next question. Obtain the expression for maximum height of projectile motion. So, for maximum height, it is Vy square is equal to Uy square minus 2gh. Now, what will that be? Final velocity is 0 and Uy obviously U sine theta square minus 2gh. Okay. Now, from this, you can easily rearrange it and find the formula for h. So, h will be u sine square theta divided by 2g. That's all. Okay. Next is the question. A projectile is projected at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second. Calculate its time of flight. So t will be what? 2u sine theta by g. Yeah. U is what? 20. Sine theta is sine 30 divided by 10. Yeah. Chetan, I have not uploaded a link. I said I will upload it. Okay, I have not done a class on physics numericals. Once I do the class, I will give you the PDF after the lesson. Okay? When is your physics exam? Yeah, if you let me know when your physics exam is, I'll do it before your physics exam. Okay. Can the expression for horizontal range? See, horizontal range is what? This range, the maximum distance it can go along x-axis. So for that, it range is basically the distance. Distance is what? Speed into time. So since this is along x-axis, speed is along also along x-axis into time. Time we already know is 2u sine theta by g. You multiply the 2, you will get u square sine 2 theta by g. Okay. Next question. Problem. A stone of mass 2 kg is tied with a string of length 1.5 meter. It is rotating in a circle with a constant speed of 10 meters per second. Calculate its centripetal acceleration. So, centripetal acceleration is v square by r, which is 10 by 1.5 square. So, you will get 66.67. Next question is from laws of motion. First question. Write Galileo's experimental observation of motion of objects on a single inclined plane. So, what was Galileo's observation? Okay. So, whenever a ball is rolling down, if there's an inclined plane, okay, there's a ball rolling down, it acquires speed and covers equal distance and equal intervals of time. Okay. Now, imagine the ball is going on a lower incline. Imagine the ball is rolling from a lower incline, which is from here. Okay. So here acceleration will be less compared to the first one. Now if it is like this, here, then there is no acceleration. Yeah. So as we go, the incline increases, acceleration increases. As the incline reduces, acceleration will reduce. And when it's flat, acceleration will be 0. And the ball will move with uniform velocity. Yeah. Okay. Explain inertia of rest, inertia of motion, and inertia of direction with examples for each. What is inertia of rest? See, inertia is the tendency of an object to remain in its state of whatever it's doing. So, for example, if I'm simply sitting on a chair and I feel like I like sitting on a chair, I don't want to do anything, and then my mom comes and tells me, go study. I don't want to because I'm in inertia of rest. Yeah, I'm sitting on a chair and I like to sit on the chair. That's inertia of rest. Now, inertia of motion is what? You're running a race very fast. You will not be able to stop in a second. You will be able to stop by slowing down and then stopping. That is inertia of motion because your body is running, your body wants to continue running until and unless you're made to stop. Okay? And inertia of direction is if you're driving for a long time in the straight direction and you don't want to rotate, turn. So because you're comfortable in that straight direction, that's inertia of direction. Yes, Manita, you can. Okay, you can. You can just visit our website. Yeah. Okay. Show that impulse of a force is equal to change in momentum produced in the body. What is impulse? Impulse is force into time. Yeah. Force is also already change in momentum by change in time. So I can say force into change in time is change in momentum. So I can easily say this is the same as impulse. So impulse is change in momentum. Okay. Okay. Next question. What are important points to be noted about Newton's third law of motion? First thing, action. For every action, there's an equal and opposite reaction. So the forces are in opposite direction. And they are not on the same body, they're acting on different bodies. Yeah? So, example two gravitational force or two contact force, anything like that. Next question. What are concurrent forces obtain the direction of equilibrium of concurrent forces? So, concurrent forces, if you have so many forces that if they have so many forces, okay, and they're acting simultaneously at a single point, yeah, if they're acting simultaneously at a single point, then you can say that they are at equilibrium, okay. And F1, F2, F3, if you add them all, the total force will be 0. Yeah. State the laws of limiting friction. Limiting friction is independent of the area of contact. It's directly proportional to normal reaction and it acts in the direction opposite to impending motion. State two laws of kinetic friction. What are the laws of kinetic friction? Kinetic friction, it does not depend on velocity between surface. It is proportional to normal reaction between the surface and it is always less than limiting friction. What are the advantages of friction? Or why can you say friction is an evil? Sorry, disadvantages. See, friction can cause a lot of wear and tear. See, your tire, it continuously rubs against the ground when you are riding, right? So what happens to the tire? Eventually the tire wears out. You have to change the tire. So that's a disadvantage of friction. If friction was not there, then you would never have to change your tire. You would not be able to drive as well because you won't have a grip. That's why when you drive on sand or drive on oil, you fall. That's because the tire and the road has no friction. Okay. It results in loss of useful energy as heat, which means when you rub, there's a lot of heat happening. Yeah. Noises and reduce efficiency in mechanism. There's a lot of noise. So if your door and all, if you don't put oil, there's a noise. So that can be that is because of a lot of friction. Yeah. How can you remove that? By oiling it. Okay. Three methods to reduce friction. Lubricating, using ball bearings, polishing surfaces. All that helps reduce friction. Chetan, you're going to hostel tomorrow. What can I do, Chetan? I'm having a class right now and I won't be able to provide you PDF for numericals today because I have to prepare it, right? I'm working on it because when I prepare some content, I make sure I take things from different sources and give you the best. So I will need some time to finish preparing it. Yeah. So it won't be possible tonight. Yeah. Let me know when your exam is. When is your midterm exam, Chetan? I can try to get it done. Upload it in Vedantu Karnataka channel. Yeah. Next question. Derive an expression for maximum speed of circular motion on a car on a level road. So if you have a path like this, okay, and let's say you have a car. Students, is there a disturbance? Please let me know if There's some kind of a sound disturbance because okay, 8th October. Is it on 8th October for all of you students? Okay, so derive an expression for maximum speed of circular motion of a car on a level road. So when a car is moving on a circular road, they have friction. Yeah, friction will be mu ng. Yes. Centripetal force needed would be how much? Centripetal force needed would be mv square by r. And both of these should be equal for it to move on a circular path. So mu ng should be equal to mv square r. From that you get V max is root of nu gr. Okay. So Chetan, what you can do is, well, I've already done a class on 5 markers and I think the PDF is there in Vedantu Karnataka Telegram channel, 5 mark important questions. Okay. So you can take a printout of that PDF that has numericals. I've not discussed the numericals in the video, but that has a lot of numericals. That should definitely help you. Okay. Yeah. Next question. A body of mass 25 kilogram moving initially with a speed of 15 meters per second brought to stop with an average retardation of 2.5 meters per second square. How long does the body take to stop? So V is equal to U plus AT. Yeah. So V is what? 0. So 0 is 15 minus 2.5 into T. So when you rearrange it, you will get 6 seconds. Okay? Yeah. Constant force acting on a body of mass 5 kg changes its speed from 4 meters per second to 7. So 4 to 7. What is the magnitude of force? How do I find acceleration? 7 minus 4 by 2 is 1.5. So force will be m into a, which is 5 into 1.5, which is 7.4. Yeah. That will help you, Chetan. You can go to 5 mark important questions on Vedantu Karnataka YouTube channel. Go to the link for the notes, download it and study that. Yeah. Okay. Two billiard balls, each of mass 0.05 kilogram, moving in opposite directions with speed 6 meters per second, collide and rebound with the same speed. What is the impulse imparted to each ball due to the other? Is there a disturbance? Please let me know. Yeah. So what will I do? The total velocity is 6 plus 6. I is m delta v. Direct substitution. Yeah. A bullet of mass 0.04 kilogram with a speed of 90 meters per second enters a heavy wooden and is stopped after a distance of 0.6 meters. What is the average resistive force exerted by the block on the bullet? Again, Newton's laws of motion. V square is u square plus 2as and F is equal to mass into acceleration. Okay? If you use these two formulas, substitute, you should get the answer. I've already solved it here, that's why I'm not doing it again. Okay? Next question. Show that work done is equal to scalar product. Work done is what? F dot D, which is FD cos theta. That is scalar product. Scalar product is what? Work force into displacement. Okay? And I'm just checking on audio quality in between so the class goes well. Okay, what is meant by positive work, negative work, and zero work? Give me give an example for each. Say positive work is when force and displacement are in the same direction. So block, I'm pushing the block moves forward. Positive work. Negative work is when I'm pushing a block, but the block moves in this opposite direction. That's negative work. Zero work is when this is a block and I'm pushing to the top. Block is moving this way. Okay, so force and displacement if they're perpendicular. Okay, next question. Derive an expression for the work done by a variable force if it's graphical. Yeah? So for a variable force, the graph could be in any random direction. So if it could be like this, it could be like this. Any random direction. Okay? Yeah? So how would I find work done? Work done is the integral of F dx. Force into change in displacement. Okay? Next, distinguish between conservative and non-conservative force. How will I do that? Already I've done that here. Already I've discussed in one markers. It does not depend on path. The other one depends on path. So the total work done is zero. Here it's non-zero. Example is gravitational friction. Okay. Next question. State and prove work energy theorem for constant force. State and prove work energy theorem for constant force. Hi, good evening, everybody. Okay, so how will you do that? Work done is force into displacement. Yeah. Work done is also mass into acceleration into displacement. Now, equation of motion states that V square is equal to V naught square plus 2AS. Yeah. So AS is equal to V square minus V naught square by 2. Yeah. Now what will I do? I'll write W is equal to M into, instead of A and S, I'll write V square minus V naught square by 2. And then I'll open the brackets. Half M V square minus half M V naught square. Same steps I've written on the other side. Typed it out. Okay? Madam lagging. God Gaming says there's a lag. Can you quickly let me know if there's a lag, students? Still lagging, very much lagging. It's not recorded, it's live, okay? I'm here. Yeah. Tanisha, can you let me know if it's lagging now also? Okay. Next question. Derive an expression for gravitational potential energy. So what is the expression for Newton's second law? F is equal to ma. So I'll write it as F equals mg. So W equals F cross H, mg cross H. So I will get U equals mg. One important factor that you need to remember here. One important factor that you need to remember here is what is it? The work done that is stored as gravitational potential energy. Yeah. Work done is always stored as gravitational potential energy. It's good now. Okay. Work done is always stored as gravitational potential energy. Next question. Derive the expression for potential energy of a spring. So how do I get that? I already know F is equal to minus K times X. And work done will be what? Force into displacement. Force is Kx and displacement is dx. So multiplying them and doing the expression, you will get half kx square. Hi Shivaraj. Okay, next question. Show that kinetic energy of the object on reaching the ground dropped from a certain height is equal to gravitational potential energy at the initial height. Okay, so let's say total mechanical energy is equal to mechanical energy at the bottom, yeah, plus mechanical energy of at the top. Okay, so at the top, mechanical energy is what? Kinetic plus potential. Potential is mgh plus kinetic is 0. Now at the bottom, potential is 0, but kinetic is half mv square. Okay, yeah, yeah. Now you equate the two. So mgh is half mv square. M and M cancel. V will be 2 square root of 2gh. Okay. Yes, at the end of the session, I will provide the PDF. Don't worry. Next question, state and prove law of conservation of mechanical energy. How will I prove that? Prove that I should say work done is what? Change in kinetic energy, which is kinetic energy final minus kinetic energy initial. Yeah. Work done is also negative of change in potential energy, which we just discussed. So it's minus potential energy final minus potential energy initial. Yeah. Now, since energy is conserved, both these should be equal. Yeah. So when you open the brackets, you will get kinetic energy final plus potential energy final should be equal to kinetic energy initial plus potential energy initial. Total mechanical energy is conserved. Yeah. Yes. Okay. Next, a force of dash newtons is applied over a particle which displaces from its origin. Calculate the work done. You just have to multiply I components, J components, and okay. Next question. A man pushes a roller with a force of 50 newtons through a distance of 20 meters. Calculate the work done if the handle of the roller is inclined at an angle of 600 with the ground. So work done is Ft cos V, cos theta. So it's 5 into 20 into cos 60. So you'll get 500 joules. Okay? Okay, next chapter. Write three kinematic equations of rotational motion of a body with uniform angular acceleration and explain their terms. So what are the formulas? They're very similar to linear. You just have to, compare and learn. So V is equal to U plus AT. So instead of V, we'll write omega. Instead of U, we'll write omega naught. Instead of acceleration, we'll write alpha. Now, instead of theta, instead of displacement x, we'll write theta. If you know these things, then we can directly write. So instead of v square is equal to u square plus 2as, what will it become? Omega square equals omega naught square plus 2. A is alpha, x is theta. Okay, that's all. Next question. What is the rotational analog for the equation dw equals f dx? Prove that power equals tau times w. So what is dw? Tau into d theta. Yeah. So p is what? dw by dt, which is tau times d theta by dt, which is tau into omega. Okay. Next question, relation between angular momentum and momentum inertia. Prove that torque equals I alpha. So what do? I take torque as dl by dt and I as dw by dt. So this will become I alpha. Okay? Yeah. Scalar and vector product differences you should be knowing by now. We discussed so many times. So you can just refer this table. Yeah, vector product, scalar product. Explain the principle of moments of lever. Again, clockwise moment should be equal to anti-clockwise moment. So F1 D1 should be equal to F2 D2. Yeah. So what is moment? Force into displacement. So force into displacement on one side should be equal to force into displacement on the other side. Obtain the relation between linear velocity and angular velocity. So angular velocity omega is what? Yeah. Omega is what? D theta by dt. Yeah. Now to convert omega into V, what we have to do is, if you take V as r d theta by dt, then this will become omega. Yeah. So basically you can write V is equal to r times omega. Okay. Yeah. Students, I will consider all your requests, but I want you all to subscribe to the channel. Quickly send this link to all your friends and subscribe to the channel. Let's quickly make it 40k subscribers. Yeah, it's 34k subscribers. It's 33.9. Quickly, let's make it 34k. Okay, and then let's keep the channel going so I can give you all the content that you're asking for. Okay, now derive the expression for kinetic energy of a rotating body. What is kinetic energy? Half MIVI square. Okay. Now when it's converted into rotational, it becomes MI RI omega square. Yeah. So you will get half I omega square. Quick problem. Two masses, 2 kgs. Yes, Tanisha, I see it. I'll try. Okay. Yeah. Two particles of mass is 2 kgs and 4 kgs are at 2 meters and 4 meters respectively. Find the coordinate of center of mass. So x center of mass is going to be equal to m1x1 plus m2x2 the whole divided by m1 plus m2. Yes, m1 plus m2. Okay. So it will be 2 into 2 plus 4 into 4 divided by 2 plus 4. So it will be 3.33. Next question. Find the torque of a force 2i cap minus 3j cap plus 4k cap over the origin. The force acts on a particle whose position vector is I plus j minus k. So first thing you need to know, if you have cross product, how to do it, that is what you need to know. So torque is equal to R cross F. Okay. So torque is equal to, let's say I, j and k. What are the first terms? 2i minus 3j plus 4k. So 2 minus 3 and then 4. So here it will be 1. No, it's R first. So R first. Sorry. Order is very important, okay? R cross F. So R terms first. R terms are 1, 1, minus 1. F terms are 2, minus 3 and 4. Okay? So when you multiply, how do you do the cross product? So what you do is, first thing, for I cap terms, you ignore the row and column that has I cap. And you take this as the matrix, you cross multiply them. So you can see the terms will be I cap into, first 1 into 4, 1 into 4, minus 1 into minus 3, minus 1 into minus 3 I cap. This is the first thing that you will have. Second, for j cap, what you will do is, you will ignore the row and column with j cap. Okay, you'll ignore the row and column with j cap, and then you'll take this term, this term, this term, and this term. So let's look at that. And always put a minus. This minus is common. First I cap minus j cap. So what are the terms? 1 into 4 minus 2 into 2, 1 into 4 minus 1 into 2, j cap. Plus, for k cap, what will I do? I will ignore the term and row and column having k cap. So now what remains? This much. Okay. So it will be 1 into minus 3 minus 1 into 2. 1 into minus 3 minus 1 into 2 into k cap. Yeah. And then you just have to solve it. You will get the answer. Alright. Okay. Next question. A meter stick is balanced on a knife edge at its center. When two coins, each of mass 5 grams, each of mass 5 grams, are put on the top of the other at 12 centimeter mark, the stick is found to be balanced at 45 centimeters. What is the mass of the meter stick? Okay, so let's look at that. So the mass into 5 should be equal to 2 into 5 times. What is the difference? 45 minus 12, which is 2 into 5, it will be 33 times 10, and then you just get the answer. Okay. So these questions in detail, I've explained in my previous videos. Please watch my 3 markers where you can get these. Now gravitation, what is Kepler's laws? 3 laws. First is laws of orbit, law of area, law of periods. What is the law of orbit? Every planet moves around the sun in an elliptical orbit with sun as the focus. Law of area, a line joining a planet and the sun sweeps equal areas in equal intervals of time. Third law, square of time period is proportional to cube of semi-major axis. So t square is proportional to r cube. Okay. Okay, next question. Derive the relationship between g and g. Derive the expression for acceleration due to gravity at a point on the surface of the earth. Okay, so let's say F equals mg. So F is what? Gmm by r square. Now when you equate the two, you will get mg is gmm by r square. So g is gm by r square. Next question. Assuming the expression for orbital velocity of a satellite at a height h, derive an expression for its time period. So we already know v is gm by r plus h, and it's rotating the earth. So time period is what? 2 pi into radius by velocity. So 2 pi r plus h by v. You equate it, you will get this. Okay? Yeah. Quick question. The acceleration due to gravity on moon is 1.7 meters per second, and its radius is 0.27 times the radius of the earth. Calculate the ratio of mass of the earth to mass of the moon. Yeah. So gm is 1.7. Rm is 0.27 times the radius of the earth. So 0.27 times Re. And then you take the ratio. Let's take, we know that Ge is me by r square and gm is mm by rm square. So I'm going to divide the two. I'm going to divide these two. Okay. I'm going to divide these two. Okay. Now, Yeah, I can divide these two. So this will be what? ME by MM will be GE by GM into RE by RM, the whole square. So when you substitute, you will get 79. Next question. Mass of the Earth is 80 times that of the Moon and the radius of the Earth is 4 times that of the Moon. If the acceleration due to gravity on Earth is 9.8, calculates its value on the surface of the Moon. So we already know G is what? GM by R square. Yeah. So if you have GE by GM, it will be what? Same steps. ME by RE square by MM by RM square. And then simple substitution. So the relationship that you need to know is GM is what? GE by 5. Okay, that's the relationship between GM and GE. Okay, next question. The escape velocity on Earth is 11.2 kilometers per second. Find the escape velocity on a planet whose radius is 2 times that of the Earth and mass is 3 times that of the Earth. Okay, so mass will be 3 times mass of the Earth and radius will be 2 times the radius of the Earth. So we have to substitute it in that way. Okay, so by RP, so which is square root of 2G 3ME divided by 2RE. Okay. Okay. Next question. You can work it out as a homework question. Already its solution is there. What homework question? No? Saturn year is 29.5 times Earth year. How far is Saturn from the Sun? If Earth is 1.5 into 10 raised to 8 kilometers from the Sun. Kepler's third law. T square is proportional to R cube. That's all that I've used here. Okay? Next question. An Earth satellite is in a circular orbit at a height of 200 kilometers above the Earth's surface. If the radius of the Earth is 6,400 kilometers, find the orbital velocity. So R is equal to RE plus H. Yeah. So V is equal to square root of GM by R. Substitute, you'll get the answer. Or if you quickly do it and let me know if you're getting 7.8. Yeah. Only refer to the solution after you've done it. Okay. Okay, let's look at this question also. A rocket is fired from the Earth towards the Sun. At what distance from the Earth's center is the gravitational force on the rocket zero? Okay. So let's say gm by x square is equal to r minus x square. Yeah. Gm by x is gm r minus x square. Gg cancel. Equate. What will you get? X is equal to, wait, square root of me by x is ms by r minus x. So I will square the whole thing. These two sides I will square. So what will it become? No, I don't have to square. I'll just rearrange. Y square. Just rearrange. Okay. And you will get the answer for x. Okay. Okay. So now we will start with 5 markers. So before that, we'll take a small little break. RXBTCC, how are you? I'm going to start for second PU classes soon. Okay. So probably Tuesday you will have a class for second PUC. Don't worry. Okay. Now it's 7:20. After 15 minutes. Yeah. Or if you can quickly go have your dinner. Is it too early for dinner? Quickly go roam around, have a break, and then we'll continue at 7:35. Yeah. Hello, students. Welcome back. Yes, I'm also back with some energy. Next, we'll discuss the 5 markers. So, from the first chapter, you don't get a lot of 5 mark questions. Okay, it's mainly related to dimensions, how to find them and all that. Yes. Yeah, I'm audible and visible. Okay, yeah. Um, the main 5 marker that you're going to get starts from chapter 2, motion in a straight line. So first question will be to derive an expression of x equals v naught t plus half a t square. This I've already discussed in the previous 3 markers. So what you do is you find out the area of the triangle and rectangle and then you multiply and get the formula. Okay. Now from motion in a plane, derive an expression of, wait, here I'll just show it to you. So this is a rectangle. I'm teaching you shapes. A rectangle, triangle. Okay. And then you find out the area of the rectangle first plus area of triangle together gives you the equation of motion. Excuse me. Okay. Yeah. Hmm. So what is the area of the rectangle? U into T or V naught into T plus half times T times V minus V naught. Yeah. So this is equal to V minus V naught. I can write it as acceleration. Yes. I can write it as acceleration times time. So V naught T plus half T V minus V naught. I can write it as AT. So this will be VT plus half AT square. Excuse me. So next is derive the expression for magnitude and direction of resultant of two vectors. So I already explained this for see the main difference between 3 markers and 5 markers are 5 markers you have to write all the steps. 3 markers they might ask you only the final equation. For 2 markers they might ask you only the final equation. Yeah. So these are all not new content. So we'll just go through them quickly. Yes. So R is equal to a square plus b square plus 2ab cos theta and angle between them is going to be equal to sin alpha by b sin theta by r. Tan alpha is b sin theta divided by a plus b cos theta. So here one thing that you need to know is the angles. Okay. So if this is a side and let's say this is an angle. Okay. If this is b, then this is alpha. So sin alpha and b will be opposite. So the angle will always be opposite to the side. Okay. Obtain the equation for path of a projectile or show that the trajectory of a projectile is a parabola. Again, I will draw the picture. Okay. And this is u. So u has two components, u cos theta and u sin theta. Now the trajectory means the path. So along x-axis is what? U cos theta into time. Along y-axis is, the equation of motion is along y-axis. So along y-axis it is x is equal to ut plus half at square. That's the formula. So you substitute that. So x is equal to ut plus half at square. So here it's not along x-axis, the equation of motion is along y-axis. So this becomes y is equal to, instead of u, it becomes u sine theta because along the y-axis, right? Into t, instead of acceleration, it becomes minus acceleration due to gravity because it's going up. Minus half gt square. Okay, so this is going to be u sine theta t minus half gt square. Now we already know from the previous formulas t is what? X divided by u cos theta. So here, instead of this t and this t, I'll write it as x divided by u cos theta. Here, x square divided by u square cos square theta. Now the sine theta and cos theta together forms tan theta. So this will be x u as well. X tan theta minus gx square divided by 2u square cos square theta. So that's going to be the final answer. And this is similar to equation of parabola. The equation of parabola is what? Ax square plus bx plus c. Okay, so this is similar to the equation of parabola. Next question. What is centripetal acceleration? Derive the expression for centripetal acceleration. So centripetal acceleration is acceleration that is directed towards the center and it makes the body move in a circular path. Okay, so let's say the small angle delta theta, small time delta t. So acceleration is what? Change in velocity by change in time. A small change in velocity by small change in time. So to make it angular, what will we do? Multiply it with delta theta by delta t. Yeah. So what we get is omega is v by r, delta theta by delta t is omega. And when you do it, you will get the final answer as v square by r. Okay. Okay. Next question. A footballer kicks a ball at an angle of 30 degrees to the horizontal. Okay. So along the horizontal, he kicks the ball, making an angle of 30 degrees. Okay. With an initial speed of 20 meters per second, calculate the maximum height and the horizontal range reached by the ball. So this is the footballer kicking the ball. We have to find out this maximum height that the ball reaches and this, which is a maximum range. So if I throw from here all the way till here, maximum range it can go. Okay. So maximum height and maximum range is what we have to find out. Let's find out the formulas for both. What is the formula for maximum height? So you need to know these formulas. Otherwise, when you're doing a problem, a numerical problem, you can't sit and derive the formula there, right? So you need to know the formulas. So h is equal to u square sine square theta by 2g is the formula for maximum height. The formula for maximum range is r is equal to u square sine 2 theta by g. Yeah, these are the two formulas. Now what is the next step? Basic substitution. Yeah, simple substitution. How will we do that? Let's just do the substitution part. Okay. So it's going to be h is equal to u is what? 20 square into sine square theta is what? Sine square 30. Sine 30 is what? 0.5. So 0.5 square. The whole divided by 2 into 9.8. The rest you can do basic math. Solve it and quickly let me know if you're getting 5 meters. So I want you all to pause the video, solve it and check if you're getting 5 meters. If you're getting 5 meters, good. Very good. Good to go. Even if you're not getting 5 meters, try again. That's all. Okay? Next, to find out horizontal range, what will we do? This is the formula. U square sine 2 theta by g. So what is u? 400 into 0.866. The whole divided by gravity is 9.8. So R will be 346.4 by 9.8, which is 35.35. So the horizontal range is going to be 34.64. Are you all getting 34.64? So here 2 theta. So 2 times theta, 2 times 30 will be sine 60. Yeah? Okay? Quickly let me know in the chat if you're able to do it. Next question. Laws of motion. State Newton's second law of motion. State Newton's second law of motion, hence derive the relationship F equals ma where the symbols have their usual meaning. Or state Newton's second law of motion, arrive at an expression for force acting on a particle of mass m producing an acceleration a. Okay. So let's say the momentum. Okay. Momentum p is what? Mass times velocity. Yeah. And we already know force is what? Change in momentum by change in time. So this is what? D by dt of P will be mass into velocity. So now what we'll get is F is equal to m into dV by dt, which is basically F is equal to m into A. Okay? Yes? Done? Okay. Next question. State and prove the law of conservation of linear momentum in the case of two colliding bodies. Yeah? So if you have two bodies that collide with each other, we have to prove that linear momentum is conserved there. So how will you do that? So first, we have to arrive at the principle of conservation of linear momentum for two bodies colliding while moving along the same straight line. So how do we do that? So first thing is, F is mass times acceleration. All of us know that can be written as m times dv by dt. Yeah. So can I write F1 to be m1 times d1 by d2, and that can be equal to minus m2 times dv2 by dt. Yeah. So F12 in the forward direction is equal to minus F21 in the backward direction. Yeah. So m1 d1 v1 by d2 is equal to minus m2 dv2 by d2. Okay. And then when I equate them to one side, what will I get? I will get to add them. So I'll get to add them. Okay. And together it will be 0. Okay. Now what will I do? I'm going to integrate them. So what is dv by dt? It's basically v1 minus v2. Sorry, v1 minus u1. Change in velocity. Yeah. So dv1 is final velocity minus initial velocity. Similarly, dv2 is final velocity minus initial velocity. Okay. And then when you equate them, you'll get m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. That's the final answer. Okay. Okay. Next question. Derive an expression for maximum speed of a car on a banked road in circular motion. Obtain the expression for maximum speed with which a vehicle can safely negotiate a curved road Okay, so we have to find out the maximum speed by which a vehicle can safely move along a curved road. Okay, so for no, we already know centripetal force is what? mv square by r, and horizontal force is n sine theta. N cos theta is mg. So if this is your car, okay, mg is acting downwards, n cos theta is acting upwards. Yeah. Similarly, n sine theta and mv square by r are acting in the same way. That's why how we get these two equations. N sine theta equals mv square by r in one direction, n cos theta and mg in the other direction, and you just divide the two. Sine theta by cos theta, tan theta, and then mv square by r divided by mg. M and m will cancel. V square by rg is rg tan theta. Okay? Yeah. Next question. A driver of a car moving at speed 25 meters per second sees a child on the road 70 meters ahead and stops the car. Okay. So there's a driver on a car. Okay. And this much is 70. And then he sees a child here. And then he stops the car at a distance of 20 meters from the child. He sees the child at 70. He stops the car 20 meters away from the child. We have to find out the time taken for the car to stop. So first thing what I'm going to do is I'm going to use the equation of motion. Okay. The equation of motion is v square equals u square plus 2as. Now what is my distance? The distance I took to stop. From my car to the time when I saw the child, I took a distance of 50 meters to stop. Okay. So my distance is 50. Acceleration is a. 25 is my velocity. Yeah. So from that I will get acceleration to be minus 6.25. Can you neatly look at it? Yeah. So F is equal to MA, which is 1000 into minus 6.25, which is minus 6250. Okay. So V will be equal to U plus 80. So 0 will be equal to 25 minus 6.25 into T. So time will be 4 seconds. Yeah. Okay. Yeah. Next question. A body of mass 2 kg is acted upon by two perpendicular forces 4 newtons and 3 newtons. Calculate the magnitude and direction of the acceleration of the body. So if F is equal to square root of 4 square plus 3 square, this will be 5 newtons. So acceleration is what? F by m, which is basically 5 by 2, which is 2.5 meter per second square. Now theta would be what? Tan inverse of the 2. Tan inverse of y by x. So 3 by 4, which is 36.87. Okay? Okay. Next question is work energy theorem. Work energy theorem for variable force. How will you do that? Work energy theorem for variable force. For a variable force, work done over displacement dx is dw equals fx dx. Yeah? F is what? M into dv by dt. What is F? M into dv by dt. Now what I'm going to do is I'm going to multiply and divide by dx. So you can see there's a dx on top and dx at the bottom. Yeah. And this dx by dt, I will write it as v. Yeah. Dx by dt, I wrote it as v. So now we have mv dv by dx. Yeah. Now we already know work done is what? F dx. So this is basically mv dv by dx is f into dx. Yeah, dx cancel. What we have is mv dv. And then basic integration, you will get kinetic energy. Yeah, so this is what this is basically tells us work done is equal to Kinetic energy final minus kinetic energy initial. Okay. Next question, derive an expression for potential energy of an elastically stored stretched spring. How do we find the formula for potential energy? First equation, Hooke's law. F equals minus kx. dw is F external dx. F external is kx. So dw is kx dx. And simple integration you will get u is equal to half kx square. Okay. So now what we should know here is work done is always stored as potential energy. So if work done is half kx square, potential energy is also half kx square. Okay, next question. Show that spring force is conservative. Okay, how do I show that spring force is conservative? dw is f dx. F is what? Hooke's law minus kx dx. Okay, and if the total work done is from x1 to x2, then w will be x1 to x2 minus kx dx, which is minus kx1 to x2 x dx. Okay. Okay. And then you do the integration. Okay. So work done is x1 to x2, upper limit minus lower limit. K is constant, so I'll take that outside. X dx. What is the integral of x? X square by 2. And then limit is x1 to x2. So this becomes x2 square by 2 minus x1 square by 2. That's all that I've taken here. Okay. Okay. Next question. Show that total mechanical energy of a freely falling body under gravity is conserved. So let's say U equals mgh. Yeah. Kinetic energy is half mv square. So total energy is k plus u, which is half mv square plus mgh. And then when you do the math, you will get E is equal to half m 2g h naught minus h plus mgh. So opening all the brackets, you will get mgh naught minus mgh plus mg. This is basically mgh naught. And this is the total mechanical energy, which is a constant. Okay. Okay. Next question. Derive an expression for the velocities of colliding particles after collision in one-dimensional elastic collision. Discuss special cases. All these special cases I've already taught you in lectures, but here let's see. So conservation of linear momentum is what? m1u1 plus m2u2 is equal to m1v1 plus m2v2. Yeah. Now, when we're applying conservation of kinetic energy, what does it become? Initial kinetic energy should be equal to final kinetic energy. Okay. So initial kinetic energy is what? Half mu1 square plus half mu2 square is equal to half mv1 square plus half mv2 square. All the common terms cancel. Yeah. No. Now it's the special case. Special case. In inelastic collision, the first special case is what? u1 minus u2 is equal to minus of v1 minus v2. Yeah. So let's use that. Yeah, this is one special case. There are many more special cases when we are substituting the values for v1 and v2. Okay. What we are getting is m1 minus m2 u1 plus 2m2 u2 divided by m1 plus m2. The only difference here is u1 term becomes u2. Okay. Here also it becomes m2 u2 m1 u1. All the other terms are the same. So for you to remember, you can remember it that way. Only the green highlighted terms are going to change. All the other terms are going to be the same. Okay. Now, whenever there's an equal mass, next special case, whenever there's an equal mass, then the velocities exchange. Yeah. So V1 will be equal to U2 and V2 will be equal to U1. The velocities will exchange. Okay. And then the equations become these. These two. Okay. Now, if M1 greater than M2, then what happens? V1 will be approximately equal to U1 and V2 will be approximately equal to 2U1. Okay? Yes. Next question. Derive an expression for the loss of kinetic energy when a moving particle collides with another particle at rest in a completely inelastic collision in one dimension. Okay? So let's say you have two particles. Okay, this M1 moving with velocity U1, it collides with another particle M2 moving with velocity U2. Okay, they both collide. So according to conservation of momentum, what happens? After collision, these particles will stick together and they'll move with a common velocity V. Okay, and they'll move with a common velocity V. So using conservation of linear momentum, you can say that M1 U1 is equal to M1 plus M2 into V. Yeah. So V is equal to M1 U1 divided by M1 plus M2. So, okay, now this is step 1. From this I get the formula for V. Now for step 2, initial kinetic energy is what? Half M1 U1 square. Final kinetic energy is what? Final kinetic energy is M1 plus M2. Why? Because these two are individually coming, they're hitting and then they're moving with the same velocity. So the final kinetic energy will be M1 plus M2 together. Okay. And V square value I substitute from my previous and then I will get this equation. Okay. So loss of kinetic energy is what? Kinetic energy initial minus kinetic energy final is equal to half m1 u1 square minus half m1 square u1 square divided by m1 plus m2. Okay. And then I take this outside. So what will I get? I'll get half m1 u1 square m2 divided by m1 plus m2, which is my kinetic energy. That's lost in collision and it's converted into other forms like heat, sound, deformation, blah, blah, blah. Okay. Next is the system of particles and rotational motion. So first thing first. So let's show that torque is equal to rate of change of angular momentum of a particle. Okay. How do we do that? How do we show torque is equal to rate of change of angular momentum of a particle? So first thing, we know torque is L cross P. Okay. Which is what? R cross mv. Momentum is mass into velocity. So R cross mv. Now what I'm going to do is I'm going to differentiate. So what I'm going to do is I'm going to differentiate. I think I'll write it down. That's easier. So L is equal to R cross mv. So dl by dt is equal to d by dt of R cross mv. Yeah. So dl by dt is equal to dr by dt cross mv plus r cross m into dv by dt. So dl by dt is equal to v cross mv plus r cross ma. Yeah. dv by dt is a. Next, dl by dt is equal to, this is 0, so the rest is r cross ma. Ma is f. So r cross f, which is actually tau. So from this, I can straight away write it is tau. Yeah, I can say tau is what? Tau is dl by dt. Okay. Okay. Next question. You need notes, Akash. The notes would be uploaded on the Vedantu Karnataka Telegram channel. Okay. Yeah. Okay. Define center of mass. Assume that the expression for velocity of center of mass show that the center of mass moves as if all the mass of the system is concentrated at the center of mass and all the external force were applied at that point. So what is center of mass? Center of mass is the point where total mass is concentrated. Yeah. So let's say there are three masses M1, M2, M3 at different positions R1, R2, R3, Rn. Okay. So the center of mass will be at the center, where not necessarily at the center point where all that is concentrated. So the formula is R equals M1 R1 plus M2 R2 blah blah blah. Now if you want to differentiate it, what you'll do is you'll take velocity, which is dr by dt. So all the R terms will now change into D terms. That's all. Okay, and then generally you can write it with summation. Same thing with summation. Okay, next one. Derive the expression for acceleration due to gravity at a point above the surface of the earth. Okay, so let r be the radius of the earth and m be its mass. Let g be the acceleration due to gravity. So if you're taking a point at a height h above the earth's surface, the distance from the center of the earth is what? R plus h. Yeah. So according to Newton's law of gravitation, gh is what? Gm by r square, which is Gm divided by r plus h square. Yeah. So G is what? Gm by r square. So Gh is G times r divided by r plus h. Are you getting it? Mm-hmm. Okay. Okay. Derive the expression for acceleration due to gravity at a point below the surface of the earth. So to find it at a below point, so if this is the earth, I need to find the gravity at a depth d. Okay. So let's say this whole thing is the radius of the earth. Now r dash will be how much? The full radius of the earth is r, and I need to find it at a point at a depth d. So r dash is going to be r dash is going to be r minus d. Okay. So step one is what? Finding out m dash. So finding out the mass. Mass is what? Volume into density. It's a sphere. So 4 by 3 pi r cube into density rho. Okay. Now acceleration due to gravity at distance r from the center is what? G is equal to gm dash by r square. So this is going to be equal to g into 4 by 3 pi r cube rho by r square. Okay. So this is going to be 4 by 3 pi g rho r. And on the surface, when r is r, what you'll get? G is 4 by 3 pi g rho r. And then simple substitution. Okay. G dash is gr by r. So g is equal to 1 minus d by r. So g dash is g into 1 minus d by r. Next question. Hi Rajesh, how are you? Quickly, all of you quickly like the video. Let's make it a lot of likes in today's class. Derive an expression for gravitational potential energy of a particle at a point due to Earth. So F is what? Gm by r square. Yeah. We also know work done is what? Minus FdR. Yeah. And potential energy and work done, they're the same. So you equate them. So you will get U is equal to R to infinity minus Gm by r square dr. Okay. And then integrating, your final answer should be minus Gm by r. All the steps are here. So I'm not going to explain the steps. It's all direct. It's all here. Explanation also I am here. Okay, Rajesh. Yeah. Okay. Obtain the expression for escape velocity, escape speed for an object from the surface of the earth. So energy is what? Half mv square minus gm by r. Okay. At infinity, far away from the Earth, kinetic energy and potential energy are zero. So EF is zero. For escape velocity, what should happen? Total energy must be at least zero. So EI should be greater than zero. Yeah. So half mv square is equal to gm by r. So VE is what? 2gm by r. So VE is 2gr. So your final answer will be that escape speed from the surface. So if you want to, launch a rocket and it has to escape the earth, it should move with a speed which is square root of 2gr, where r is the radius of the earth. Okay, next question. Derive an expression for orbital speed of a satellite around the earth. Okay, so F is what? Gm by r square. F centripetal is mv square by r. Now when you equate the two, this becomes gm by r square is equal to mv square by r. So v square is what? Gm by r. V is square root of gm by r. Yeah? Why? Because this is in a circular path. So centripetal force should be equal to the force between the two. Okay, next question. Obtain an expression for energy of an orbital satellite. So we'll start by taking energy as kinetic energy plus potential energy. What is kinetic energy? Half mv square. Potential energy is minus gmm by r. Yeah. So when you're equating, we will get v is gm by r and v square is gm by r. So kinetic energy is what? Half mv square. V square is gm by r. So kinetic energy is half m into gm by r, which is basically gmm by 2r. Yeah. So energy is what? Gmm by 2r. So we will get energy equals gmm by 2r. Okay. Next question. Check Kepler's law of area of a planet. Show that law of area follows the same law of conservation of angular momentum. How will you show that? So what is Kepler's second law or law of area? It says that a line joining a planet and the sun sweeps out equal areas in equal intervals of time. So we are going to prove this using conservation of angular momentum. So let's consider a planet of mass m moving around the sun in an orbit. Okay. So let r be the position vector of the planet and v be the velocity. Okay. So let there be an area delta A. Okay. Let time be delta t. Okay. So we know that. Let's take a triangle. Okay. Let me draw that for you. So if this is the orbit, it will form a triangle. This is the sun, this is the planet. So it sweeps out equal areas in equal interval of time. So the area of the triangle will be what? Half times height will be radius times base will be r delta theta. So this is going to be half r square delta theta. Yeah. Now for a small area, I will take dA by dt. So that will be half r square d theta by dt. Yeah. So angular momentum L will be what? Mr square d theta by dt. So equating the two, you will get dA by dt is L by 2m. Okay. Now, yeah. So since gravitational force is central and there's no external torque, you can say angular momentum L is conserved. So you can say L is a constant. dA by dt is a constant. Hi Viru, hi Rajesh. Okay. So last question for the day. Describe Cavendish's experiment to determine the value of gravitational constant. So what Cavendish did is very simple. He took two masses, okay, and he connected them on a rod, okay, two masses, one here, and he hung them. So this is free. So it can move like this. However it wants, it can move. There are two masses. Those are the green ones that you see. One mass is here, one mass is here. These are small masses. And then what he did is he took two big masses, the violet ones, and kept it at two different points. They are not connected. So what he observed is this freely hung masses slowly twisted and got attracted to the big mass. Okay, so he proved that the big masses they pulled the small mass towards them. So there was a force of attraction. Yeah, so that was how Newton's law of gravitation was invented. So the force of attraction between the big mass and the small mass together. Yeah. So the big mass is here, small masses are here, and they are, hung freely. Okay. So that's okay. You might not have been seen. Okay. Look at this picture here. So the two green masses are the small masses that was hung freely. Okay. And then the violet masses are heavy ones. And what happens? Since this is free, it can move however it wants to. So this green mass got attracted to the big one, the violet one. Okay. And then the force by which it got attracted was later found out as universal Newton's law of gravitation, and it was given by the formula F equals G m1 by m2 by r square. R is the radius, m1 and m2 are the masses, how heavy the masses are. G is the constant value. Okay, so the whole experiment is described here. Yeah, you can go through them. All the steps are mentioned. So in a summary, this is what the experiment is. Okay. So I think with that, we can wind up today's one shot. I've discussed, all the important questions. I've not gone in very much detail, but all the steps are there. Okay. So you can go through them. I will share this PDF in our YouTube Telegram channel, which is the Vedantu Karnataka Telegram channel. So you can just join Vedantu Karnataka Telegram channel to get your notes. Okay. Yes, let's all just smash the like button quickly. Smash the like button and let's and subscribe to the channel. Share this to all your friends so we can keep giving you quality content. Until then, bye bye. See you. All the best for your